Hello, folks. In this video, we'll be trying to discuss Banker's algorithm, which is used for deadlock avoidance. And in order to understand this Banker's technique, we will be taking help of a numerical. But prior to that, the idea here is that you will be given a snapshot of a system with some resources and a set of processes which are trying to utilize those resources. So we'll be given a scenario wherein processes are currently allotted some resources and are waiting for some more resources to be allocated for them. And maybe due to the lack of availability of resources or the minimal resources that we have, so we would be trying to allocate the available resources to the process to add to the current availability and see that they are able to meet their requirement and then be able to release their resources. And in the process, we will try to see that all the process are given opportunity to utilize the resources without any deadlock. So to understand this scenario here, now let us try to take a numerical here. So this is an exercise problem where we are assuming that there are 5 processes, as you are able to see here, numbered P0 till P4. So there are 5 processes and there are 4 types of resources, A, B, C, D, as you are able to see here. So the assumption is that in total, the maximum instances of resource type A is 3 and type B is 17, type C is 16 and D is 12. So these are the resource types instances what are given to us. And out of these 3, 17, 16 and 12, currently 2, 12, 14 and 12 have been already allocated to the process. Now this particular, let me highlight the pen here. Yeah, so as you are able to see here, this is the allocation matrix what you have here. Okay, now in the allocation matrix, these are the resources that I am talking about, actually A, B, C, D. And for instance, if you take P0, P0 has type A0, type B1, type C1 and type D0. So the resources have been allocated in such a fashion, and in total when you add up each of these process resources in type A, type B, type C and type D, this is the total resources which are currently allocated, right? And for a process to be able to complete its execution and be able to release those resources, we will then require a maximum allotment. So this is the maximum, by the way, all these are matrices what we call here. So this is the maximum matrix what is given to us. So this defines the maximum resources that may be used by a process basically. So for instance, type P1 requires type A1, type B6 and type C5 and type D2. So like that. So this is the maximum allotment, maximum requirement matrix here. And after allotting currently these many resources here, out of the given 3, 17, 16 and 12. So if we deduct this value here, obviously we are left with 1520. So this is a need matrix, availability matrix that is given to us basically. My mistake. Yeah. So this is the availability matrix. So currently the system has type A1, type B5, type C2 and type D0. So these are the resources available. Now with this available resources, we will try to see whether each of these process P0 till P4 will be able to meet its maximum requirement. Now, in order to be able to do that, we will first have to compute the need matrix. That is, further, after currently being allotted these many processes, further, how much does each individual process require? So for being able to do that, we need to create the first step that we need to do is create the need matrix. Now the need matrix can be computed based on this simple formula, maximum minus the current allocation, right? So these are the matrices that are given to you, as I said. So this is the maximum matrix, and this is the allocation or the current allocation. So we need to subtract the current allocation from maximum matrix basically. So maximum minus this one. So for instance, 0 minus 0. Similarly, 2 minus 1, 1 minus 1, 0 minus 0. So that would give you the need matrix of P0. That is 0, 1, 0, 0. Similarly, we will compute for each and every process that is available in the system, P0 till P4. So maximum minus the current allocation would give us the need matrix in this format. So further, each process requires so many resources for being able to come out of the system, complete their execution and come out of the system basically. And given to us is basically this availability 1520. So how this 1520 can be utilized for the allotment, further allotment, is the challenge here by being able to avoid deadlock. Now let's move on. So for being able to avoid deadlock here, we will try to take a work vector basically. So the availability, initial availability, whatever is there, that will be allotted to work. We'll start with that as the initial work. Okay. And we will try to compare the need of that each and every process, whether it is within the limits of the availability or not. So let us start with P0 first. So P0, as you are able to see, has 1, 0, 1, 0, 0. Now we'll try to compare whether this 0, 1, 0, 0 is less than or equal to, right? Less than or equal to the work, that is 1520. So we have to compare each and every number here, type A, type B, type C, and type D. So obviously, as you're able to see, 0, 1, 0, 0 is very much less than 1520. So because it is less than this, what we'll do is we will say that initially P0 was not completed actually, right? So initially P0 was not completed. Sorry, yeah. Now, because it will be able to complete, so we will try to alert this finish matrix as true for P0. But how do we do that? We will try to recalculate the work, assuming that this 1520 will be now changing such that, because 0, 1, 0, 0 is the requirement for P0. So this 0, 1, 0, 0 will be deducted from this 1520. And it will be added to the allocation matrix so that it will meet 0 to 1, 0. That is the maximum matrix of P0 basically. So I repeat again, 0, 1, 0, 0 will be deducted from the availability and then added to the P0's current allocation, which is 0, 1, 1, 0. And that would become 0 to 1, 0, which is nothing but the maximum. So once the maximum is reached, obviously it would release the resources. So instead of deducting and again releasing, what we are simply doing here is we will simply add the current allocation 0, 1, 1, 0 to the current work matrix, work vector basically. So 1520 is the current vector, current work vector. So work equal to work plus what has been allocated for P0. So that will be 1520 plus 0, 1, 1, 0. Instead of deducting 0, 0, 1, 0, 0, we are directly adding 0, 1, 1, 0 to 1520. That is 1630. So I'll repeat again. So this 0, 1, 0, 0 is being added to the work as a first step. Okay. Or for you to understand in a better way, what you can do is you can start with 1520 and you can deduct 0, 1, 0, 0. That is the requirement of P0, which would be 1420. Now because 0, 1, 0, 0 has been deducted, where would it be added? So 0100 will obviously be added to P0 here. So how much that would be? That would become 0210, which is nothing but the maximum matrix. So once the P0 reaches maximum, obviously that would release 0210. So again, you can do 0210. That would be 1630. This is the same as what we have here, right? What we have done here is, instead of deducting and adding, what we have done is we have simply taken the current work and add current allocation to the work, right? Take the current availability. So work equal to work plus allocation. That would anyway give you 1630. So like that we'll go forward for each and every process. So P0 is complete. Now, because P0 has been able to complete without any deadlock, we will mark the finished matrix for P0 as true. So we are trying to identify a safe sequence basically. So P0 will be first in order to complete its execution without any problems. Now we obviously have to think about the other process also. So let's think about P1 initially. Now P1 requires 0421. So again compare 0421 with the current availability. Now the current availability is this one. This is your availability. Okay. So compare 0421 with the current availability. So 0421 is less than work or not? Compare that. Obviously, you would think that it is less than, but take a look at the type D closely. So in type D, so P1 requires 1, but currently availability type D there is 0. That means 1 is greater than 0, which is not less here. So even if one of the type is not able to match that, we will try to see that the condition is false. So the condition is not met here. So 0421 is not less than or equal to work here. So because it is false, P1 will not be allotted the resources. So it will not be executed. Okay. Obviously, who is next in line? Now P1 didn't complete. So P2. P2, the availability, P2, the need matrix is 1001. So 1001 again compare with what is currently available. That is 1630. Again the same case. So as you're able to see here, type D is 1, but available is 0. Type D. So again, it is not matching the requirement of less than or equal to. So obviously again P2 will also be not executed. Next go for P3. So like this, we keep on repeating the iterations. Now how about P3? Let's check that. So obviously P0 has completed. P1, P2, just now we have seen is not completed. Now going on to P3. So P3 need is 0020. So 0020, compare it with the current work. What is the current work that we have? Right, 1630, as you're able to see here, the previous case. So we are trying to compare this with 1630 from the previous slide. So check whether the 0020 is less than the work 1630 or not. So each and every type, as you are able to see, is less than this. So because it is less than this, we can proceed further for allotting the resources. Now, once we are allotting, what would happen? Obviously 1630 is the current availability, and to the current availability, what would be added? The current allocation would be added. So what is the current allocation for P3? So P3, the current allocation, as you're able to see, is 0632. So this 0632 will be added to 1630 from P3's current allocation. That would give you, so these two are added here. So that would give you current availability is 11262. So obviously P3 will also be able to complete. So we'll set the finish matrix as true. Initially, all the finish of i's are false, indicating that no process is completed. But once we start allocating, obviously every process will be completing one after the other. So right now P0 and P3 have completed. Right now, moving on to the next process, that is, so P3 is complete. P4 now. So P4 requires 0642. Again, compare 0642 with the current availability what we have, that is the work vector. So the current work is 11262. So we'll try to compare 0642 with the current availability, that is 11262. That is less than this. So we'll go ahead and allot the requirement to the need of P4 to meet the maximum requirement. Now, obviously, once the maximum requirement is met, we will try to release all the resources. So for 11262, we will add the current availability. Going back to the previous slide again. So the current allocation of P4, the last process, is 0014. So 0014 will be added here. That would be 11276. That is what you get here. So obviously P4 will also go through. These are done. Now we are still left with P1 and P2. So right now the current availability is 11276 after few iterations. Now because it is 11276, again we'll go back to, these have completed. So we'll go back to P1 now. So P1 requires 0421. So check with 11276, which is the current availability, which is very much within the limit. So less than this. So that's the reason we'll go ahead and alert. Again, the work vector will now change to 11276 plus current allocation of P1. What is the current allocation of P1? Current allocation of P1 is 1231. So 1231 we added to 11276 to get 240.107. Obviously P1 has also completed. Right, so we still are left with P2. So again, perform another iteration. Now P2, the need matrix, according to the need matrix, it requires 1001. That's the last one. So 1001 is less than 24107, which is the current availability. So we can go ahead and alert. So again, using the same procedure as earlier, we will try to add the current allocation. So what is the current allocation of P2? That is 1365. So you would get 17, 16, and 12. Right. So all the process will be able to complete now if we allot in this order. So we started with P0, right? Then went for P3, then went for P4, and finally P1 and P2. So this we call as safe sequence. We allot the initial availability in this particular order. We say that we can avoid deadlocks. Right? When would we have got deadlock? We started with P0, right? And suppose we went on with P1, then it would obviously lead to a deadlock, P1 or P2. So we tried to avoid the deadlock by not allotting P1 and P2. Instead, after P1, we went for P3, and then P4, and then followed by P1 and P2. So that sums up the banker's technique for avoiding deadlock. Hope you understood this. Thank you.